If fx equals to fractional part of x, when greatest integer function of x belongs to odd, and equals to fractional part of minus x, when greatest integer function of x belongs to even, then find the value of pi square by 10 times integration from minus 10 to 10 fx cos by x dx.
Pause the video right here and try the problem by your own. Don't take more than 3 minutes to solve the problem.
Let us say m equals to box x. So the definition of the function becomes fx equals to fractional part of x when m, which is equals to box x, belongs to an odd integer, right? Now f of minus x will be fractional part of minus x. In that case, your m becomes box of minus x, right? Now previously m was box x, which was an odd function. Now m becomes box of minus x, which will be definitely an even function. Am I correct? Let us take an example. Let us say x belongs to 3 to 4, right? Therefore your box x is how much? It is 3. Now if I take minus x, then it will lie between minus 4 and minus 3. In that case, your box of minus x will become minus 4, which is an even integer. Is it clear? So when we are assuming that m is an odd integer, then we are getting box of minus x as an even integer. Now when m is an even integer, your fx is nothing but fractional part of minus x. Am I correct? So f of minus x is reduced to fx, which implies that fx is an even function when box x belongs to an odd integer. Is it clear? Now let me take the other definition. Let us say fx is nothing but fractional part of minus x. This definition is true when m, that is your box x, belongs to an even integer, right? So f of minus x is fractional part of x. Now observe, when m will become box of minus x. Now we have assumed that m, which is equals to box x, is an even integer. Now box of minus x will become an odd integer. Is it clear? Now let me take an example again. Let us say x belongs to 2 to 3. So in that case, your box x is 2, which is nothing but an even integer. Now minus of x will lie between minus 3 and minus 2. So in that case, box of minus x will become minus 3, which is nothing but an odd integer. Is it clear? Now we know when m is an odd integer from the definition, your fx equals to fractional part of x, right? So I can write here, it is equals to f of x. Therefore it implies fx is an even function when box x belongs to an even integer. Is it clear? Now the conclusion that we can draw is fx is an even function. Fx is an even function in the given domain, that is here, for all x belongs to real value. Is it clear to all of you? Have you understood this much? Let me rub the workout. Now, let us say gx equals to fx cos pi x. Okay? So g of minus x is f of minus x cos pi minus x, which gives you f of minus x cos pi x. Now just now we have proved that fx is an even function, so f of minus x can be replaced by fx only, right? So which is again nothing but your gx. Now observe carefully, your gx is also an even function. Is it clear or not? Is it clear to everyone or not? Okay. Now we know from the basic properties of definite integral that from minus a to a fx dx can be written as 2 times integration 0 to a fx dx if fx is an even function. Yes or no? Therefore, my integration in this case will become pi square by 10 into 2 times integration 0 to 10 fx cos pi x dx. Is this much clear to everyone? Okay. Now, observe it carefully that your fx is a periodic function with period 1 and cos pi x is a periodic function with period 2. Therefore, fx cos pi x is a periodic function with period 2. Yes or no? Again, from the basic properties of definite integral, we know that integration 0 to n t fx dx, where t is the period of the function fx, can be written as n integration 0 to t fx dx. Am I correct or not? Right? Now you see in this case, our integration, since fx cos pi x, the period of this function is 2, so we can write this thing as pi square by 5 integration 0 to 2 into 5 fx cos pi x dx. Now we can write this thing as pi square by 5 into 5 integration 0 to 2 fx cos pi x dx. Is it clear? Therefore, our integration reduces to, let me rub the upper portion. Therefore, our integration I reduces to pi square integration 0 to 2 fx cos pi x dx, right? Now I'm writing it as pi square integration 0 to 1 fx cos pi x dx plus integration 1 to 2 fx cos pi x dx. Am I correct? Now when x lies between 0 and 1, your box of x gives you 0, which is an even integer. So this fx will be replaced by, according to the definition of the function, fractional part of minus x. When x lies between 1 and 2, in that case your box x becomes 1, which is an odd integer, right? So according to the definition, this fx will be replaced by fractional part of x. Is it clear to everyone? Okay. Therefore, our integration becomes pi square integration 0 to 1 fractional part of minus x cos pi x dx plus integration 1 to 2 fractional part of x cos pi x dx. Is it clear? So we can write it as 0 to 1. When x lies between 0 to 1, your fractional part of minus x can be written as only 1 minus x, right? Plus, when x lies between 1 and 2, your fractional part of x can be written as x minus 1. These are all basic function conception. So let me separate it. Pi square integration 0 to 1 cos pi x dx minus integration 0 to 1 x cos pi x dx plus integration 1 to 2 x cos pi x dx minus integration 1 to 2 cos pi x dx, right? Is it clear? Now let me just separately do integration x cos pi x. By using integration by parts, let us take this one as my first function and cos pi x as my second function. We are getting x sin pi x by pi minus integration sin pi x by pi dx. So it's x sin pi x by pi plus 1 by pi square cos pi x. So just remember this, because I'm going to replace this value in everywhere where we will find integration of x cos pi x dx. Okay, so we are getting pi square, integration 0 to 1 cos pi x is minus Is it clear? Now let me put the values we get. Is it clear to everyone? So we are getting 4 by pi square, which gives you 4. Is it clear? Therefore, the answer of the given integral pi squared by 10 integration minus 10 to 10 fx cos pi x dx is nothing but 4. Is it clear to everyone? Okay.